Hello, participants. Thanks for your patience since morning. So we are gradually going to the end of the training. So the last aspect is to look at um, how we can actually forecast using autoregressive, a first order autoregressive model, as well as a case where we have at least one intervention variable. But before then, we shall look at how to perform stationarity test, since we know that stationarity is very important to the forecasting that we wish to do. So let's go straight to our R studio. Um, like we rightly observe when considering the PowerPoint, we can carry out about three or more stationarity tests. We have the ADF, we have the Philipperon, we have the KPSS. As to perform this in R is pretty straightforward. So let us continue with um, our maximum temperature. So it's our Tx under Ts. So the function for ADF is ur.df. That's what I call ADF underscore climb air. So this is our object. Type, we have three types. We have trend, that is you are considering the trend at the constant. Then we have drift, if you don't want to consider the trend, and we have none, in which case you are actually omitting the trend and the constant. So usually you start with the trend and check the results before you proceed to other ones. So let's run this. We select the lags automatically. In my situation, I'm using archaic information criteria. So run, and let's get the summary. Good. So if you look at our interest is the value of these test statistics. Although detailed results, you can find the detailed regression results up there. Yeah, you can find the detail there. But our concern here is the value of these test statistics here. So you consider this here. I have minus 10.4956. So you have to compare this with this tau statistics here. Um, At 1%, I normally use 1% as better. Uh, Look at the values in absolute terms to save time. You can see that the value of the test statistics is greater than the critical, in which case you reject the null hypothesis of non-stationarity. Remember, the null hypothesis here is non-stationarity. So in which case we can say that our variable is stationary at level. But let's say it's not stationary, that is, if the value is actually less than 3.98 in absolute terms, then you have to just get the first difference. Yeah. Then you run it, and you get the summary. Yeah, as simple as that. Then, like before, compare the values. Um, but here we are. It's already stationary at level, so we don't have to worry ourselves about that. Like I said, you can change this to drift, but you proceed to all these things in case uh, the trend, yeah, maybe by the time you fix the trend is not stationary. Run, yeah, then ADF, yeah, then you can try none. Case this, I'm just showing us how to handle it. Yeah, so then fine, but we already have a very nice result with strength, so we don't need to worry ourselves here. Okay, so for filiperon, um, the function is ur.pp. Then we have two types. We have z tau, z alpha. Then the model, just instead of type here, we use model. Lags is just divided into two. We have short and long. So there is no basis selecting it with any of these selection criteria. So it's either short or long. Short means it's not more than 5, which is what most of the time, that is what we use most of the time actually. So let's run it. You get the summary, you can see the interpretation. So our interest again is our interest here. That's this Z statistics. Then you consider the critical value. Yeah, so and it's the same interpretation with that of ADF. And I think I sent a textbook to you so that you can read more. And there are a lot of times in econometrics textbook to guide uh, a clear understanding of the theory behind all these um, unit root tests. Then we have the KPSS. That's, in that case, we have the type, that we have the lags, short. We try that again, get the summary. Yeah, but in this case, we have to be very careful concerning the interpretation because when you are dealing with KPSS, the null hypothesis is actually the opposite of those ones. The null hypothesis here is there is stationarity. So, and when you compare this 0.04 and this 0.119, this is less. So, which means you do not reject the null hypothesis of stationarity. Understand that. So, all of them are directing us to the same answer. But you have to be careful the way you interpret KPSS because you don't interpret it like PP and ADF. So let's look at, now that we are sure that our variable is stationary at level, so let us go ahead with understanding a few forecast model, regression based. Let's say we want to use the first order autoregressive model. So this is our object here. The function is AR. I call it model underscore AR. So order dot max, since we are dealing with first order, it's going to be 1. We are using OLS as our method. So you run this, fine. Then you can forecast. I'm forecasting, let's say H, that's the next 40 months. So let's run it. And good. Fine. So 14 months, we start from January 2019 to February 2020. Since our original data ends, I think in December 2018. Yeah. So you can auto plot. That's fine. Good. Yeah. So this is the point. Yeah. Yeah, we can have a sort of ex-ante forecast. That is, we are just considering the trend and because the trend and the season, the data set. So if that is what we just want to do, it's pretty straightforward. So you look at, this is the model now. The model I'm using is, I'm running my object against trend and season. This is a kind of ex ante, since we already know trend and season in advance. So let's run it. And again, Now you can get the summary of your model now to that's the regression that you have run to see, the R squared is okay. Then you see here you have your seasons, here you have your trend. So you can see that seasonality is very, very important here. Yeah. Now you interpret the coefficient just like you interpret normal regression because this way less anyway. Then you can use it to forecast. So if you are using this model to forecast, just forecast this for the next 14 months. So this is it here. So, and now you can look at the values. F, that's called model. Yes. Run. Yeah, so these are the value for the 14 months, and you can auto plot it. So you see the shape will be different from the one we've done. Yeah, that's fine. Now, in case you want to use uh, regressor or regressors, that is, you want to use intervention variables. Well, a typical example is trying to use stringency index. The stringency index is actually computed using various approaches to mitigate against this COVID-19. This wear mask, keep social distancing, use sanitize or all manner of things that people are using, so on and so forth. So that's what is used to calculate the stringency index for various countries. So now, if you want to use it to forecast, um, we want to use the forecast for the next 14 months. So definitely, it's a kind of scenario forecasting, which means you expect something to happen to the stringency index. Let's say we believe that, okay, in terms of the stringency index, maybe it's going to rise by, say, 10% in the next 14 months. That is, we believe that in the next, based on historical whatever, or understanding of the context of various countries, let's say we believe that it's going to rise by 10% for the next 14 months. So, and you want to base your forecast on that. So you have to generate the new data. So there are new data, the data.frame, stringency index. So we are repeating this 14 times. That is what the new data is talking about. So let's run this up to this place so that you see what we are talking about. So we can see that is we have repeated the increase of 10%. So now that you have your new data, you need to convert your stringency index to time series. Remember, um, so we change it to time series by say TS, the stringency index here, and we use frequency equals to 7. This is the ideal thing, particularly when you are dealing with daily data. So we say, okay, let the frequency be every week run. So you do that also for the total number of cases run. So the moment you have done that, then you have to run your regression of the total cases against the stringency index. So this is what I call model 2. So I run it, fine. So the moment you have run it, then you can forecast this model. You use this model to make your forecast based on the new data. It's straightforward to do in R. Very, very straightforward. So you have the model, the new data is my new data that I've generated. So this run, fine. So now you can see your forecast. Fine. So this is so you can plot it if you so wish. Okay. Um. Then, in case we are using a kind of multiple regression approach, which means we have more than one variable. For instance, we may have this stringency in index. We may need to add public holiday dummy. You may want to add several other things. In that case, I think the starting point is to first look at the scatter plots matrix of our data. So if that is our interest, so we use DGRLE package, right? So let's check the matrix. Okay. So it's taking this time to make the plots. Definitely, in the coming week is where we are going to start, so that we consider our forecasting using multiple regression. Then we proceed to various other methods, such as using mean, using naive method, using simple exponential smoothing, using ETS approach or linear. There are so many methods. So we are going to consider all these methods. We will look at them. Then we are going to consider how to select. Now we just have as many methods as possible. Then how do you now walk around and see which one should actually be used? Yeah, school is still working out the what is it called now? The scatter plot matrix. Yeah. No, we are dealing with a very big, massive data, so it may take some time. So this is where we are going to end the presentation. Now we are going to proceed to our third assignment. So try to work on the assignments. Then we are going to come together again to look at what we find out. Maybe we have some difficulties or so on and so forth. Right. Yeah.